Welcome back. Today we're going to be continuing our conversation about exponential decay, looking at the depreciation of assets, which is a fancy way of saying most stuff is worth less over time. In order to do that, we're going to look at these two models, the recursive model and the explicit model. The recursive model says that essentially how much your asset is worth or how much your principal is worth this year is essentially 1 plus the interest rate or depreciation rate if you're subtracting of what it was last year. On the other hand, the explicit model says that if you tell me how much it was worth at the beginning of this calculations, or what we would call the initial investment, and then the interest rate, again, which is R, so R is the interest rate. Let's do a little insert for that. R equals interest rate. Now, this could also be the depreciation rate or the rate at which something decays, like rate of growth or decay. Now, if it's decay, it's negative. If it's growth, the rate will be positive. And so let's look at what we have right here. With Malik's car, we want to write an explicit formula for the sequence that models the value of the car T years after driving it off the lot. So right here, we have $1,500, how much it's worth. As soon as he drives it off the lot, it's actually worth $12,750. And every year, the growth rate is actually negative, minus 15% to the T. So the principal is equal to the $12,750 is initially worth, minus 15% each year, negative growth rate, and N is the T. Now, if we're going to use the formula from Part B to determine the value of Malik's car 5 years after its purchase, we can then just substitute in for 5 in for T. Then we can type this into a handy-dandy calculator. So and if we do that, then we have that the value is exactly what we calculated with the table, or $5,657.24. Now we can repeat this whole process for 7 years, as they ask us to do in this Part D. So reading Part D, use the formula from Part B to determine the value of Malik's car for 7 years after its purchase. Round your answer to the nearest cents. So I can literally copy and paste, and then instead of typing in 7, instead of typing in 5, we type in 7. Switch over to our calculator and type in the same 7, and our value is $4,087.35. What this does is it lets us calculate for any given year. The power of the recursive model is it's very quick and it gives you an answer one after another very easily, the way that the spreadsheets actually run off of this recursive model. An explicit model actually lets you figure out something at a specific date at which you need to know it. Both models are useful, both models work well, and both models will be useful for the group practice we're doing in class today. To start you off with the group practice, take a look at number 1. If a person is given a dosage D of a particular medication, then the formula FT of D times 0.8 to the T represents the concentration of medication in the bloodstream. If Charlotte takes 200 milligrams of the medication at 6 a.m., how much is it remains in her blood at 10 a.m.? How long does it take for the concentration to drop below 1 milligram? There are a couple different ways we could do this. We could use the explicit equation, which is F of T. Let's type that in. F of T. And if she got D, a dosage of 200 milligrams, times 0.8 times O the power T in hours. And then we could say, well, if that's a situation, I can then calculate, well, 6 a.m. into 10 a.m. is 4 hours. I can then calculate F of 4 is equal to 200 times 0.8 to the 4, whatever that happens to be. Now, for the second question, you might find that type of recursive situation, a table, useful in solving it. Let's explore these together in class. I'll see you there. Have a wonderful rest of your day.